Hi guys, myself again in this video shall see another problem on LeetCode. Maximum subarray. Given an integer array num, find the subarray with the largest sum and return its sum. What is meant by subarray? So if they given an array, let's say minus 1, comma 2, comma 4, then its maximum subarray will be like its subarray will be like contiguous block of elements in an array. So alone be a subarray. Then minus 2 also can alone be a subarray. Then 4 also can alone be a subarray. So all these can be subarray. So along with this, if you need to take minus 1, minus 1 comma 2, then 2 comma 4, or the entire minus 1 comma 2 comma 4 can be subarray. But the combination which cannot be subarray is if you take minus 1 comma 4, no, this cannot be a subarray. It should be a contiguous block of elements. Only then we can consider it as a subarray. So in the given question, we have to find the subarray with the largest sum. So if we take into this subarray, the minus 1 is a sum, here 2 is a sum, here 4 is a sum, then here 2 minus 1, 1 is a sum, then 4 plus 2, 6, here 4 plus 2, 6, minus 1, 5. So maximum sum we found is 6, so that is 2 comma 4. So this is the answer which we need return. This is what the given question is. So now in brute force approach, what can be is, if you take the same example, we start with first element. Find we will have two variables. One is current sum, another is maximum sum. So both are initialized to 0. So when you find your current sum, start with the first index. In that inside nested loop you will have this one is sum minus 1. Then with this sum total minus 1 plus 2 plus 4. And you find the current sum and you compare it with the maximum sum whether it is greater or equal. If it is greater than the maximum sum, then maximum sum will be equal to current sum. So again for the next index, start with here, again to this position. And last one, 4. So this is the normal brute force approach. So if I need to give the code, this can be the code. Here you could see. So maximum sum, current sum initialized to 0. Then at each loop you have to make current sum equal 0. For this current sum is 0. Then we'll start it from the second position, we have to do the current sum equal to 0. Then we find the current sum. And here one case which you need to think is, imagine we have only one element in the array, minus 1. Then here, if I don't take into consideration this case, the maximum sum will be max of current sum comma maximum. It will be 0 and current sum will be minus 1. So which will result in 0 as answer, which is wrong. We should get minus 1 as answer. Because for this array, minus 1 is the maximum sum of the largest sum subarray. Largest sum of the subarray. So that's why if j equal to 0, maximum sum will be current sum. Or else here you can make a maximum sum equal to integer dot um, minimum value. And that also works. So this is a brute force approach. But we need better approach. This will give a time limit exceeded because it has a complexity of big of n square. Two loops we have. How do we do within a single loop? How do we get big of n as a complexity? For that, let's take the same example. Minus 2, 1, minus 3, then 4 minus 1, 2, 1 minus 4, minus 5 and 4. So as I said before, we will have two variables. One is current sum, another is maximum sum. So let both be initialized to first element of the array, that is minus 2 comma minus 2. Yeah, not 0. So for the next loop, you start from I equal to 1. We know that for maximum sum, of course, it will be max of maximum sum comma current sum. That is for sure. What is the other thing we need is to find the current sum now. We start with minus 2, right? We initialize with current sum and maximum sum will be minus 2 initially. Then you go here. Now current sum equal to either this one element, single element 1, or the previous current sum plus particular element nums of I. So current sum equal to other nums of I, or current sum plus nums of I. The nums of I is 1. Maximum of these two. So current element is my 1, and current sum plus nums of I will be minus 2 plus 1. Current sum is minus 2 plus 1 will be minus 1. So the maximum of these two is what? 1. Because it makes sense. No? So instead of taking the sum as um, minus 2 plus 1, which is minus 1 smaller than 1, we could take 1 itself because this is the maximum sum that will be possible. So that is current sum. Next, you compare it with maximum sum. So now current sum equal to 1. So 1 and minus 2, which is maximum? 1. So maximum sum will also be 1. That is what we do here. Next, go more to this position. Here again, you check whether 3 is maximum or current sum, whatever you had, plus 3. Is minus 3, sorry. Current sum is 1, minus 3 will result in minus 2. So which is maximum of these two? Minus 2. In negation, the smaller number is the maximum number. So minus 2 is maximum. So current sum will be again minus 2. What about maximum sum? The maximum of these two is 1 itself. So it will remain as it is. So what the difference between current sum and maximum sum? Maximum sum we find the maximum of maximum sum and current sum. But for current sum, what we do? We take this particular element, it either only this element or the previous summation of the current sum. We check whether that which is maximum of those two. So it's basically a dynamic programming approach. So next we move to this position 4. Either 4 only or previous current sum is minus 2, right? So minus 2 plus 4, it will result in 2, which is the maximum of these two, that is 4. So current sum is 4 by now. And maximum of 4 and 1 is of course 4. So maximum sum will also be 4. So now if you look into this, uh, if you observe what we did is, initially the sum was minus 2. And then we got into here. So from here, 1 we got as a correct sum. So whenever you get the summation correct sum as negative, we start a new summation because we reinitialize it to 0 and we start freshly from that particular position 1. Then again, when you moved here, you got the current sum as minus 2. So again, negation you got. So you made the current sum as 0 and start freshly from here. That is 4, which is got here. So that is what Kadam's algorithm will do. So basically what it does is whenever you get current sum as negation lesser than 0, then you reinitialize it to 0. So when you reinitialize the 0, when you go to the next loop, you will firstly start the current sum. So that is what we have got 4 here. So here minus 2 you got. So you started from here. That's why you got 1. Then again 1 minus 3 minus 2. Again negation summation. So you initialize to 0 and started freshly a current sum from here. That is what you got 4. Next move here. So now either minus 1 or 4 minus 1 is 3. So now if you see observe here, this is negative number, but 4 minus 3 is positive still. So we take into account 3 in my term. So current sum will be 3 and maximum of 3 and 4 will be 4 itself. Next move here 2 and 3 plus 2 will be 5, previous sum. So maximum will be 5. So current sum will be 5 now and maximum sum will be 5 and 4 will be 5. Again you move here, so 1 and 5 plus 1 will be 6. Here also 6 as the maximum sum you got. 6 and 5 max will be 6. Then again you move here, minus 5. So 6 minus 5 will be 1. So again positive number only we have got. Whenever you get the current sum as negative, only then you reinitialize to 0. So here minus 1 comma 1. So this summation will be minus 4. The maximum will be 1. So current sum will be 1, but maximum will remain as 6 only because 1 and 6 max is 6. Then you move here. 4 or 1 plus 4 will be 5. So maximum this will be 5. So current sum is 5, but maximum sum is 6. So it will remain as it is. Hence you return the maximum sum as 6. So if you observe, we have got 4, 1, 4 minus 1, 2, 1. Because 4 minus 1, 3 plus 2, 5, 5 plus 1, 6. As the largest sum of the subarray. So the logic behind this actually what is, if you by chance you got current sum as negative, then you reinitialize to 0, and for the next step, freshly you start the sum as you see here 4 and if the current sum value is greater than 0, then you add up, go on adding the values. So we will code this. So in current sum equal to 0 or not 0, nums of 0, then int max sum equal to nums of 0, or int I equal to 1, I lesser than nums dot length I plus plus. Now at first you have to find the current sum. So just this, yeah. So current sum equals to math dot max of nums of I, comma current sum plus nums of I. Next, max sum equal to math dot max of max sum, comma current sum. So at last you return the max sum. That's it. Now the complexity is big of n. Yeah. Yeah, successfully submitted. If you have any news, please drop in the comment section. We'll come up with another video next session, and please subscribe to our channel and keep learning. Like the video. Thank you.